All right, so we're going to do a chain rule problem, but with this chain rule problem, we're also going to have to work with our product rule, because I've got two different functions being multiplied to each other, and those two functions actually have functions inside of them as well. So I have a cubed and a fourth degree function. Inside of the cubed function is a quadratic. Inside of the fourth degree function, I have a linear function. All right, so we're going to use product as product with our chain. Right? So remember, product rule says take your first piece, which is x squared plus 1 to the third power, keep that the same, multiply it by the derivative of the second piece. Remember, it's chain rule. So take the 4, bring it to the front, subtract that exponent by 1, so we end up getting x minus 4 to the third, multiply it by the derivative of the inside function. The derivative of x minus 4 is 1. All right, now you're going to add your second piece, which is x minus 4 to the fourth, and you're going to multiply it by the derivative of your first piece. When you take the derivative of your first piece, it is chain rule. So drop your exponent, keep x squared plus 1 the same, all right? Subtract your exponent by 1, so that's your power rule. Now you're going to multiply it by the derivative of your inside. Derivative of x squared plus 1 is 2x. All right, so let's start rewriting some of this stuff. Bring your first terms together, and then multiply what you can on the backside. So this is what you'll end up getting. I reordered the back, so I kept the x squared plus 1s in the front when we were multiplying, and the x minus 4s to the later part of it. All right, when you get to this point, if you want to stop right there, you can. We took a derivative. At this point, it's all algebra now. We are going to start to simplify, so I'm going to find a GCF, and I'm going to start to see what they all have in common. So the GCF actually becomes 2, and then x squared plus 1 squared, and then x minus 4 cubed. So I'm looking at the 4 and the 6x. I know I can factor out a 2 from both those. They do have some x squared plus 1s in common. The largest that they have in common is 2. They have some x minus 4s in common. The largest that they have amount in common is 3. So now we're going to go to the next page. We're going to take this GCF away from both of that stuff, all right, from all that stuff. So we're going to start doing that right here. So there's my GCF, the 2, x squared plus 1 squared, and x minus 4 cubed. And what's going to be left over is 2, x squared plus 1, and then 3, x times x minus 4, all right? So that's what we have at this point. I factor out the GCF. This is what was left over. All I'm going to start to do is I'm going to start to work with all of this stuff. I'm going to start to distribute. I'm going to start to combine like terms. Okay. So we get our GCF in front, which hasn't changed, and now start to distribute. So you end up getting 2x squared plus 2 plus 12x squared minus 12x. Or I'm not sorry, minus not 12x, minus plus 3x squared. Okay. Then once you have all that stuff distributed, go ahead and combine some like terms. 5x squared minus 12x plus 2. And there's your derivative. So lots of stuff. That was all extra. That was all doing some algebra. Remember, if you want to, you can come back here, and this piece right here is actually your derivative. What we ended up doing was we started to simplify, and this is what the derivative simplifies to. So it's up to you. Do you want to keep moving further with it? If you don't, leave it as is. If you like to simplify and you're good at it and you understand it, go ahead and simplify, but it's not required.